Oh my, I skipped a couple of problems there when I wrote down the examples. I skipped G and H. So let's take a look at G. It's a trinomial again. G, trinomials, perfect square trinomial? Well, let's see. Yeah, that's a perfect square, so let's get the root there. G, is that a perfect square? Yep, that's a perfect square there, so let's get the root there. And then is 2 times each of the roots, 5x and 4y. So that's 20 times 2, which is 40xy. Yep, absolutely. This is a perfect square trinomial. Remember, perfect square trinomials get small when we factor them. So we have the root, and we have the root, and then we have the middle sign in the middle. And there we go. That is our perfect square trinomial factored. All right, now coming down to our last one here, we see that we have not a perfect cube, not necessarily not a perfect cube, and we see cubes here, right? So I know that's kind of what I'm after. So theirs are both even, so let's take out a 2. So if I take out a 2, I end up with y cubed for the first term, plus 2 goes into 5 2 times, with 1 left over, and 2 will go into 14 7 times. Now I have 2 perfect cubes, so y here and 3 here. So now I'm going to rewrite this as, don't forget my GCF, and then prepare for my binomial, prepare for my trinomial, and then root and root, root squared, product of roots, always plus root squared. And then whatever the middle sign is goes in my binomial, the opposite of that goes in my trinomial, and voila, I'm all done. And so those are all your turn problems. Now in our next lecture, we're going to talk about how to apply these to some concepts in chapter 12. So we're going to be just practicing our factoring, but we're going to practice it to apply to adding and subtracting rational expressions.